Beneath the crushing weight of oceans, beneath layers of shifting sands, there may lie ruins the Earth itself has chosen to forget. Monuments turned to dust, cities dissolved into stone, whispers of civilizations erased long before humanity ever learned to carve its first tools. The Earth is ancient, older than the imagination dares to grasp, and its memory is not easily shared. Humanity looks upon itself as the pinnacle of progress, the first and only intelligence to rise from this world of oceans and rock. Yet the question lingers, unsettling and unrelenting. What if we are not the first? What if, in the cycles of deep time, others rose before us, built, dreamed, expanded, only to vanish into silence, leaving nothing but faint echoes in the geological record? This is the heart of the Silurian Hypothesis, a scientific idea born not of fantasy, but of inquiry. If an industrial civilization once walked this Earth millions of years ago, would we even know? Or has the planet already buried every trace, folding evidence into its crust, erasing history with floods, tectonic shifts, and time itself? The stakes are not only about the past, but the future. For if intelligence has come and gone before, what does that mean for us? What fate awaits our own fragile civilization, built upon sands as shifting as those that may have swallowed others? If we are not the first, then perhaps we will not be the last. But how many times has the Earth already forgotten? Before we continue, share your thoughts. Where are you listening from? And do you believe humanity is truly the first civilization on this planet? If this question stirs your curiosity, gently support the journey ahead with a like and a subscribe so the exploration may reach even further. Human beings have always sought to measure themselves against time. In the earliest myths, civilizations imagined golden ages lost to floods, or ancient peoples erased by fire. The Greeks spoke of ages of bronze and iron, the Sumerians of kings who ruled before the flood. These were not yet sciences, but whispers of a suspicion that history may be deeper and stranger than memory allows. As tools sharpened and eyes grew keener, ruins became more than the remnants of fallen kingdoms. They became questions. Beneath desert sands, in jungle overgrowth, under the tides of forgotten coasts, fragments of vanished cultures emerged. Yet even these, the pyramids, the ziggurats, the broken temples, were but shallow scratches in the vast ledger of time. Humanity began to suspect that the Earth itself carried histories stretching far beyond the memory of people. The birth of geology in the 18th and 19th centuries revealed this with breathtaking clarity. James Hutton, Charles Lyell, Georges Cuvier, each helped tear open the curtain of deep time. They discovered layers of stone as pages in an ancient archive, written over eons with the imprints of vanished seas, forests, and creatures. The fossil record spoke of worlds older than imagination, entire ecosystems rising and vanishing. Extinction, once inconceivable, became undeniable. Charles Darwin entered this unfolding revelation with a theory that tied life itself to the Earth's deep history. Evolution became the long arc of time, life branching, splitting, collapsing, and beginning anew. Extinction was no longer an accident, but an inevitability, a rhythm written into the planet. If species could vanish without a trace, why not civilizations? Paleontology gave humanity its first glimpses of vanished worlds. The bones of leviathans, the teeth of giant reptiles, the delicate impressions of ferns pressed into shale, each was a fragment of lives that no longer walked the Earth. Yet for all their grandeur, these discoveries raised another paradox. If vast empires of species could vanish almost without a fossil trace, what chance would a fragile civilization have against the same abyss of time? The idea lay dormant, unspoken, until a new generation of scientists turned its face once again toward the stars and back upon the Earth itself. In 2018, astrophysicist Adam Frank and climatologist Gavin Schmidt posed the question directly. Their paper, published in the International Journal of Astrobiology, carried a title that felt less like science and more like myth: the Silurian Hypothesis. They asked, if an industrial civilization had existed on Earth millions of years ago, would we be able to detect it today? The answer, they suspected, was far from certain. It was not a fanciful question, but a scientific one. The Anthropocene, the era humanity now inhabits, will itself leave a geological footprint. Sudden spikes of carbon dioxide, synthetic isotopes, plastic polymers, concrete, aluminum. But how long will these last? Plastics degrade, metals corrode, concrete erodes. In 10 million years, in 100 million, what evidence would remain? Frank and Schmidt argued that our own civilization's geologic signature could be surprisingly faint. And if ours is faint, then any civilization that preceded us may have already been erased. Plate tectonics recycles the seafloor, burying and melting evidence. Erosion grinds mountains back into sediment. Even nuclear isotopes decay. The Earth forgets, and it forgets quickly. On scales of millions of years, the Silurian Hypothesis drew its name from a story, an echo of speculation older than the science itself. In the 1970s, a popular television series imagined ancient reptilian beings, the Silurians, who had achieved advanced civilization long before humans, only to retreat underground. Though fictional, the metaphor remained haunting. Could Earth itself harbor forgotten chapters, erased not by aliens but by time? What made the hypothesis unsettling was not merely its novelty, but its plausibility. It connected geology, paleoclimatology, and astrobiology in a single thread. If life emerges, if intelligence builds, and if civilizations collapse, would their memory survive in stone? And if not, then how many stories has Earth already buried beneath its shifting skin? Speculative though it was, the Silurian Hypothesis was no flight of imagination. It was rooted in testable science, in chemical signatures, isotopic anomalies, climate cycles, and the patterns of mass extinctions. It took inspiration from science fiction, yet its foundation was an empirical question, one with implications for how we search for life, not just on Earth, but on every world beyond. Thus, the discovery was not of ruins unearthed, but of a new way to look at the Earth itself. The planet became not just a stage for human history, but a vast and ancient palimpsest, a book written and rewritten across deep time, where entire civilizations could rise, vanish, and be forgotten, leaving only a question to disturb the silence. Were we truly the first? The Silurian Hypothesis strikes at the heart of human self-image. Civilization has long told itself a story of uniqueness, that intelligence was inevitable, that the rise of cities, science, and technology is the singular achievement of one species at one time. But the hypothesis cuts through this myth with chilling simplicity. It whispers that humanity's ascent may not be the first, and therefore may not be the last. It forces us to imagine an Earth where intelligence has bloomed before and vanished without leaving a trace. The shock is not just in the suggestion, but in the science that makes it plausible. Geological time is vast beyond comprehension. To think in centuries or millennia is natural for human history, but the Earth measures itself in millions, even billions of years. Against this backdrop, the span of human civilization is no more than a blink of an eye. 10,000 years of agriculture, 5,000 years of writing, a few centuries of industry, set against 4.5 billion years of planetary history. The scale itself reveals the danger. In such immensity, even civilizations can vanish like shadows. Consider what happens to evidence across those spans. Fossilization is extraordinarily rare. Only a tiny fraction of organisms ever escape decay and are preserved in stone. Most vanish, their traces scattered in dust, ash, or water. Entire ecosystems leave behind only fragments. A shell layer, impressions of leaves pressed into sediment. If the mighty dinosaurs who dominated Earth for 160 million years were known to us only through incomplete skeletons and scattered fossils, terror of the hypothesis. Not that no one looked, but that even if we searched, there might be nothing left to find. To see this more clearly, scientists turn to the Anthropocene, the current epoch shaped by humanity. What traces will our civilization leave behind in the distant future? Today, we are certain our impact is overwhelming. The carbon we burn changes the atmosphere. The plastics we discard litter every ocean. The concrete we pour covers the earth like a new crust. Yet even these mighty imprints are not guaranteed to last. Plastics degrade into dust, dispersed and transformed. Metals corrode, rusting into oxides. Concrete, though resilient, cracks and dissolves over millennia. Nuclear isotopes decay into stability. In 10 million years, the gleaming towers of our cities will be gone. The vast webs of roads will be weathered into invisibility. Satellites will have long since fallen from the sky and decayed into fragments. The fossil record will bear only a thin chemical scar, a sudden spike of carbon, traces of rare isotopes, unusual concentrations of metals. Even this record could be obscured by later geological upheavals, leaving only faint anomalies buried deep in ancient layers. This revelation shatters intuition. Human beings believe ruins last forever, that monuments defy time. The pyramids, the Great Wall, the statues carved into stone, these are thought of as eternal, yet even they are but temporary sculptures in an ever-eroding world. In 100,000 years, they will crumble into sand. In 1,000,000, they will vanish completely. In 10 million, there will be nothing left to suggest they ever stood. If this is true of our civilization, why would it not be true of another? If others came before us, if they built, expanded, and consumed as we do, then their fate would be no different. They too would have been erased by the Earth's restless geology. Their monuments crumbled, their machines corroded, their traces scattered until indistinguishable from the natural background. The Earth is not a museum. It is a forgetting machine. The fearful implication is clear. If others rose and fell before us, they are invisible to us now. We would not know them. Their presence would be reduced to anomalies in the carbon record, unexplained shifts in climate, sudden bursts of extinction. We might already be looking at their tombstones without recognizing them as such. This realization expands outward, transforming from a geological observation into a cosmic one. For if civilizations can vanish so thoroughly on Earth, then what of other worlds? How many planets in the galaxy might bear scars of forgotten civilizations, their stories lost in shifting crusts and eroded oceans? If intelligence is common, its disappearance may be equally common. The silence of the stars, the Fermi paradox, may be explained not by absence, but by erasure. Thus, the shock of the Silurian hypothesis is twofold. It challenges humanity's sense of uniqueness, and it confronts us with our fragility. Our history, our monuments, even our very existence may be less permanent than we imagine. Against the slow grinding of geological time, civilization is ephemeral. The Earth has buried countless worlds already. Forests, oceans, creatures. Perhaps it has buried civilizations too. The question now becomes not only whether others came before, but whether we ourselves will one day join them. What will remain of us when the Earth has finished with its patient work? A chemical scar, a trace of isotopes, a faint anomaly buried in stone, and perhaps, like them, nothing more than a question whispered into the silence of deep time. To test the haunting question of the Silurian hypothesis, scientists turn from imagination to the language of the Earth itself, geology, chemistry, and climate records. If humanity's brief presence leaves behind traces that can be measured in stone, then perhaps buried deep within ancient strata, we may yet glimpse the echoes of civilizations long vanished. The first step is to ask, what is the fingerprint of an industrial society? What indelible marks does human civilization impress upon the Earth's surface? The list is sobering. Plastics, produced by the billions of tons, now infiltrate every corner of the planet, from the peaks of mountains to the deepest trenches of the sea. Concrete, poured in amounts that rival natural rock formation, covers continents in an artificial crust. Synthetic chemicals and pesticides seep into soils and rivers. Metals, refined and scattered, appear in concentrations no natural process could achieve. And then there are the isotopes, strange, unnatural, radioactive signatures born from nuclear reactions, carbon-14 from atomic testing, plutonium-239, cesium-137, elements with half-lives measured in thousands to millions of years. They do not exist in nature. They are our civilization's unmistakable signature, written into the strata of the Anthropocene. Beyond the artifacts themselves, our civilization's greatest imprint may be upon the atmosphere. The burning of fossil fuels has produced a dramatic spike in carbon dioxide, altering the very chemistry of the air and oceans. This change will be etched into the geologic record as a sudden anomaly, a sharp line, a disruption in the natural rhythm of carbon cycles. For future geologists, millions of years hence, this spike will be unmistakable. It will be as visible to them as the thin layer of iridium that marks the asteroid impact which ended the reign of the dinosaurs. If our society leaves these signatures, then the question follows: do similar signatures exist in the ancient past? Have there been sudden, unexplained anomalies in Earth's deep record that cannot easily be attributed to natural causes? One event looms large in this search: the Paleocene-Eocene Thermal Maximum, or PTM, roughly 56 million years ago. In this brief geological instant, spanning perhaps 200,000 years, the Earth's temperature spiked by 5 to 8 degrees Celsius. Vast amounts of carbon were released into the atmosphere and oceans. The source remains debated: volcanic eruptions, methane hydrates, or the burning of organic carbon. Yet the anomaly is striking. The carbon isotopic ratio shifted dramatically, as though the Earth had been flooded with carbon from a concentrated source. The PTM triggered mass extinctions in the oceans, profound changes in ecosystems on land, and a reorganization of climate across the planet. Could this have been the fingerprint of an earlier industrial civilization? Mainstream science suggests natural processes, yet the Silurian Hypothesis insists on humility. If we did not know the Anthropocene was human-made, would we interpret it as natural? If future geologists studied our own epoch without cultural context, would they assume it was volcanic, or glacial, or cosmic in origin? This is the paradox that haunts the investigation. Natural events can mimic the signatures of civilization. Massive volcanic eruptions can flood the atmosphere with carbon dioxide. Methane releases can alter isotopic balances. Asteroid impacts can spread exotic elements across the globe. To distinguish between the natural and the artificial is almost impossibly difficult, especially across millions of years. And yet the PTM is not the only anomaly. Throughout Earth's history, there are sudden warming events, extinction pulses, and carbon spikes. Each may have been natural. Each may also conceal a forgotten story. Beyond carbon, scientists look for geochemical signatures that are more resistant to time. Synthetic isotopes are compelling candidates. While many decay quickly, some leave traces for millions of years. Rare earth elements, scattered by human technology, might form unusual concentrations in soils or sediments. Heavy metals, refined by industry, might appear in deposits where they do not belong. Even plastics, though fragile, may transform into long-lived microparticles, fossilized within sedimentary rock. These, too, could be the residue of civilizations erased by time. The search extends beyond rocks into the great archives of ocean sediments and ice cores. The oceans are Earth's memory, slowly layering centuries of chemical change upon their floors. Ice, when preserved, locks bubbles of ancient atmosphere in crystalline cages, preserving the breath of ages long past. By drilling into these repositories, scientists can reconstruct the story of climates, extinctions, and planetary upheavals. Within them lie abrupt shifts, anomalies, and puzzles, spikes of carbon, strange isotopic balances, chemical scars without simple explanation. Yet always the same caution returns. Absence of evidence is not evidence of absence. The Earth is not designed to preserve history. It is designed to renew itself. In the span of 100 million years, even the clearest markers may fade or vanish. Erosion erases, tectonics consumes, chemistry dissolves. Civilizations, if they existed, may have been erased so thoroughly that we will never know. The investigation deepens, not because evidence is abundant, but because evidence is fragile. The possibility of earlier civilizations cannot be dismissed, not because we see their ruins, but because we understand how easily ruins vanish. This is the unsettling truth revealed by science. The Earth itself is an unreliable narrator. Its story is full of silences, gaps, and erasures. What we call the geologic record is less a complete chronicle than a fragmented palimpsest, rewritten by fire, water, and stone. And so the search continues, through rocks, through sediments, through isotopes and anomalies. Each unexplained event, each carbon spike, each extinction pulse becomes a question mark. Was this merely the work of natural catastrophe? Or was it something more, something intelligent, something industrial, something erased? The deeper the investigation, the more profound the realization. The line between natural and artificial is blurred, perhaps irretrievably so. And in this blur lies the haunting possibility that Earth has hosted more than one intelligence, more than one civilization, more than one story of rise and fall. The deeper one peers into the Earth's story. The more unsettling the silence becomes. The surface of our planet is not an open book, but a restless ocean of stone, constantly rewriting itself, erasing its own memory. Mountain ranges rise and crumble, oceans expand and contract, continents drift, fracture, and collide. With every tectonic movement, layers of history are folded under, melted, and transformed into new rock. In this ceaseless process of recycling, time does not preserve, it devours. If an ancient civilization once stood upon this earth, its towers scraping the skies, its machines reshaping the world, its traces may already lie buried miles beneath our feet, subducted into the mantle, reduced to molten anonymity. The ocean floor itself, a vast archive of sediments, is constantly renewed. The oldest seafloor on Earth is no more than 200 million years old, a mere fraction of geologic time. Anything older has already been swallowed by the deep. The Earth is not a museum of permanence, but a forge of renewal. This realization sharpens the Silurian hypothesis into something more unnerving. Perhaps we are not incapable of finding evidence of earlier civilizations, but blind to what may already be present. How many anomalous isotopic spikes, unexplained extinctions, or climate events have we cataloged, dismissed as natural, and moved on? Perhaps the fingerprints of intelligence are already etched into the strata, yet so well disguised by natural processes that we cannot separate artifice from catastrophe. Here lies the first escalation of terror, the possibility that civilization is not unique, but cyclical, that Earth may have witnessed not one rise of industry and intelligence, but many. Civilizations bloom, climb toward mastery of their world, and collapse, leaving behind only chemical whispers, indistinguishable from volcanic fire or methane release. Each cycle ends in silence, and the slate is wiped clean for the next. This cyclical vision is not without precedent. Human history itself is layered with forgotten civilizations. Great empires swallowed by deserts, jungles reclaiming once mighty cities, oceans hiding the ruins of ancient coasts. If this can occur over thousands of years, how much more complete must the erasure be across millions? The terror is not in the possibility of discovery, but in the certainty of forgetting. From a cosmic perspective, the implications are staggering. If Earth can so thoroughly erase civilizations, what of the countless exoplanets orbiting distant stars? Astronomers now estimate that our galaxy alone may host billions of Earth-like worlds. Many may have birthed life. Some may have birthed intelligence. Yet if their fates mirror ours, then their histories too are written in erasable ink. Civilizations may rise, falter, and vanish, never reaching beyond their homeworlds, never leaving lasting signals across the stars. This thought echoes the great filter, the paradoxical silence that haunts our search for extraterrestrial intelligence. If life is common and intelligence is possible, then why does the universe remain so quiet? Perhaps the answer lies in this hidden cycle. Civilizations do not endure long enough to shout across the void. They collapse under their own weight, undone by catastrophe or by themselves. their evidence erased by the very planets that nurtured them. Here, the Silurian hypothesis touches upon a far deeper existential question. What if humanity is not unique, not the first, not even the exception, but simply the latest? If Earth has hosted intelligence before, and if intelligence always ends in collapse, then we too may be walking a well-worn path toward disappearance. Our skyscrapers, our machines, our satellites and digital archives, all of them destined to dissolve into anonymity, indistinguishable from natural processes millions of years from now. The mystery deepens further still when extinction events are reconsidered. The Earth's fossil record is punctuated by sudden and violent die-offs. The Ordovician, the Devonian, the Permian, the Triassic, the Cretaceous, each is attributed to natural catastrophe, asteroids, volcanism, climatic upheaval. But what if, in some distant case, these extinctions were not merely natural? What if they were the echoes of civilization's ending? Industrial collapse, planetary destabilization, self-destruction. The possibility is unnerving, not because evidence points to it directly, but because the erasure is so complete that we cannot disprove it. The deeper we dig, the more fragile our sense of uniqueness becomes. The possibility that others have walked this path before us, rising toward the stars and falling back into silence, unsettles the foundations of human pride. The thought that our Anthropocene may itself be only another fleeting chapter in an endless cycle is both humbling and terrifying. The Silurian hypothesis, once a speculative question, now becomes a mirror. It reflects not just the past we cannot see, but the future we may be destined to follow. Are we unique, or merely another ripple in a long-forgotten tide? The Earth does not answer. Its silence is not reassuring. It is accusatory. The planet erases its own history, and with it, perhaps the memory of civilizations that came before. And so the terror deepens, not in what we know, but in what we cannot know. The Earth is a forgetful witness, and in its forgetfulness lies the possibility that we are not the first and will not be the last. The Silurian hypothesis was never intended as an answer. It was posed as a question, a thought experiment framed by Adam Frank and Gavin Schmidt. If an advanced civilization had once flourished on Earth millions of years before humanity, how would we know? The power of the idea is not in proof, but in the framework it provides for searching. It shifts speculation into science, asking, what markers would such a civilization leave, and can we detect them within the vast archive of the Earth? The first hypothesis is deceptively simple. Industrial societies leave behind carbon scars. Humanity's own Anthropocene will be remembered not in stone temples or digital archives, but in the sudden and dramatic spike of carbon dioxide that reshaped the climate. This anomaly will etch itself into the geologic record, visible for millions of years as a sharp, unnatural line. If others came before, they too may have burned fuels, altered the climate, and left behind the same signal. The Paleocene, Eocene Thermal Maximum becomes the prime candidate. A sudden warming, a sharp isotopic shift, a world thrown into chaos. Was it volcanic, or was it industrial? Without context, the distinction blurs. The second hypothesis pushes deeper. Advanced civilizations might leave behind isotopic fingerprints, rare elements, synthetic materials, and radioactive isotopes that do not exist in nature. Human technology has scattered uranium and plutonium isotopes across the globe, embedded cesium and strontium in soils, and concentrated rare earth metals in ways geologic forces never would. If such signals exist in older strata, mixed into crusts or ores, they might be the ghostly residue of societies long gone. Yet the longer the span of time, the more the Earth's cycles dilute and erase, making detection ever more tenuous. The third hypothesis touches upon fragility itself. Perhaps earlier civilizations never reached beyond their homeworld. Humanity has only just begun to place artifacts beyond Earth. Probes drifting into interstellar space, rovers wandering distant planets, satellites orbiting our skies. But if collapse comes swiftly, such attempts might never occur. A society could rise, alter its planet, and vanish without leaving a single trace beyond its world. If this pattern repeats, it explains not only Earth's silence, but the silence of the cosmos. From these foundations, the speculation widens into broader, more haunting theories. One of the most sobering is the Great Filter. It suggests that there is some nearly insurmountable barrier between the rise of life and the flourishing of interstellar civilizations. Perhaps life itself is rare. Perhaps intelligence is fleeting. Perhaps self-destruction is inevitable. If the Silurian Hypothesis hints at past civilizations erased, then it offers a chilling vision. The Great Filter may already be behind us or ahead. If ahead, it is a warning that collapse, not survival, is the norm. Others look to the Rare Earth Hypothesis. It argues that intelligence itself may be almost impossibly uncommon. The chain of events that produced humanity, a stable star, a magnetic field, plate tectonics, a moon to steady our axis, a balance of oceans and continents, may be so unlikely that even on Earth, advanced intelligence could have arisen only once. Yet the Silurian Hypothesis whispers otherwise. If the conditions for civilization have already been met more than once on the same planet, then perhaps intelligence is not unique, but cyclical. Perhaps Earth itself is a cradle that repeats its experiment over and over again. The Zoo Hypothesis adds another layer of speculation. It imagines that civilizations, whether on Earth or across the stars, may be part of a broader cosmic pattern. Like animals in a preserve, life may arise, vanish, and arise again. Its story hidden but purposeful. Its cycles part of a universe we cannot yet fathom. If intelligence returns again and again, perhaps it is not an accident, but a necessity, an emergent property of matter and time. If so, the Silurian Hypothesis is not just about forgotten civilizations of Earth, but about the very structure of cosmic history. Beyond the scientific lies a more haunting speculation still. If such civilizations once lived, could their presence echo faintly in our myths, legends, or unexplained anomalies? Tales of lost continents, sunken kingdoms, and gods who walked among mortals haunt nearly every culture. Atlantis, Lemuria, the dreamtime of the Aboriginal peoples, stories of civilizations before civilizations, worlds before worlds. These myths are not evidence, but could they be distant echoes, faintly preserved through time, of truths once lived and then forgotten? Some archaeologists dismiss such ideas as romantic fantasy, yet the psychological allure remains. Humanity's imagination returns again and again to the thought that we are not the first, that greatness has risen and fallen before. Perhaps this is nothing more than myth-making, or perhaps, as the Silurian Hypothesis suggests, it is an intuition born from the deep rhythms of Earth itself. Theories multiply, but certainty does not. Some argue that if earlier civilizations existed, we would already see their ruins. Others counter that ruins do not last, not against millions of years. Some propose that we search more deeply in ancient strata for anomalies unexplained by natural forces. Others suggest that the effort is futile, for the Earth is too efficient an eraser. Yet in this uncertainty lies the true power of the Silurian Hypothesis. It forces reflection upon the fragility of civilization. It reminds humanity that permanence is an illusion, that even the mightiest societies are temporary. It asks us to look at our own anthropocephone, not as an apex, but as a signal, one that may vanish as countless signals may have vanished before. Speculation then becomes philosophy. If civilizations can rise and fall unseen, what does it mean for us? Are we living in a singular age? Or are we merely repeating a cycle, destined to repeat again? Is intelligence rare, or is it inevitable? Are we the first, or only the latest? Theories and speculations circle endlessly, like planets around a star, never resolving, yet illuminating the vastness of the mystery. And in the silence of the Earth, where ruins are buried and memories erased, the question remains open. If civilizations before us did exist, they are gone, and we are left with their absence. Yet perhaps their greatest legacy is the question itself, the haunting thought that humanity is not alone, not even in time. To pursue the Silurian Hypothesis, science must turn from imagination to instrumentation. The question, whether advanced civilizations once rose and vanished on Earth, cannot be answered by myth or speculation alone. It requires tools sharp enough to cut into the stone of deep time, to read the fragile signatures hidden within sediments, isotopes, and atmospheres. The search begins with isotope analysis, the precise measurement of atomic fingerprints left behind by ancient processes. Carbon, for instance, exists in different isotopic forms, carbon-12 and carbon-13. Natural processes tend to leave behind predictable balances of these isotopes. Yet when vast amounts of carbon are released by industry, as in the Anthropocene, that balance shifts dramatically. By analyzing ancient rocks and sediments for similar disruptions, geochemists attempt to reconstruct carbon cycles stretching back tens of millions of years. Each anomalous spike becomes a potential signal, natural catastrophe, or something else entirely. Deep-sea drilling expands this search into the oceans, Earth's most reliable archives. Beneath miles of water lie sediments layered in delicate succession, each a page in the planet's story. Ships like the Joid's Resolution and Chikyu drill cores from the seafloor, extracting cylinders of mud and stone that preserve climates, extinctions, and upheavals. Within these layers, scientists look for sudden changes in chemistry, fossil content, and mineral structure, evidence of disruption on a planetary scale. To the untrained eye, these samples are simply mud. To the trained, they are libraries of vanished worlds. Sediment cores extend not only into the oceans, but also into ancient lakes and polar ice sheets. Ice cores from Greenland and Antarctica preserve bubbles of atmosphere tens of thousands of years old, providing direct snapshots of ancient air. While they cannot reach into millions of years, they teach us how signatures of industry imprint themselves upon the record. By analogy, sediment cores from older strata may carry traces of events like the Paleocene Eocene Thermal Maximum, spikes of carbon and heat whose causes remain debated. Satellite imaging adds another dimension, mapping the Earth's surface with unprecedented resolution. Modern instruments peer through deserts, jungles, and shallow seas, revealing ancient riverbeds, buried coastlines, and hidden geological features. While these maps are not old enough to reveal civilizations millions of years gone, they serve as practice, showing how landscapes conceal and reveal the passage of humanity itself. They remind us that Earth's surface is deceptive, and that even vast cities can vanish beneath sand or sea within a few millennia. Scientists also study the Anthropocene itself as a living experiment. If humanity vanished tomorrow, what would remain millions of years from now? Plastics may fragment, but in their abundance some may fossilize as plastiglomerates. Stone mixed with plastic, preserved as an unnatural hybrid. Concrete, though fragile compared to natural rock, may remain in scattered deposits. Synthetic compounds, pesticides, refrigerants, pharmaceuticals may linger as chemical ghosts, and nuclear isotopes, though decaying over time, leave traces that no natural process would reproduce. These markers form the baseline. If geologists of the far future found such signals in their rocks, they might suspect the presence of an advanced society. By studying our own layer, scientists refine their sense of what to look for in deeper time. Future missions aim to push this search further. More ambitious drilling projects may probe strata, older than any yet studied, looking specifically for anomalies unexplained by natural cycles. New geochemical methods may detect subtler signals, trace metals, isotopic oddities, chemical residues that elude current techniques. The goal is not to prove the existence of a lost civilization, but to sharpen the tools, to prepare science for whatever signals lie buried in Earth's restless crust. The search need not be confined to Earth alone. Mars, with its ancient and relatively stable surface, offers a tantalizing comparison. Unlike Earth, much of Mars's crust has remained unchanged for billions of years, preserving a geological record that Earth has long since recycled. If industrial civilizations existed elsewhere, Mars might retain their traces far better than Earth. Already, rovers have found evidence of ancient rivers, lakes, and potential habitability. If Earth's history can be erased, Mars may one day become the silent witness. Venus offers a darker reflection. Once, it may have been temperate and ocean-bearing before a runaway greenhouse effect transformed it into a world of fire. If civilizations could arise on Earth and collapse, could they also have emerged on Venus before its fall? The planet's surface has been reshaped by volcanic upheavals, concealing much of its past, yet its atmosphere may hold chemical clues waiting to be unraveled by future missions. Beyond the solar system, exoplanet research pushes this line of inquiry into the stars. Astronomers now study the atmospheres of distant worlds, analyzing starlight that filters through them. Already, these techniques can reveal water vapor, methane, and carbon dioxide. In the future, they may reveal industrial signatures, unusual chemicals, synthetic compounds, or heat patterns that cannot be explained by geology or biology alone. To search for alien civilizations is also, indirectly, to learn how to detect the ghost of a civilization on Earth. If we can imagine industrial markers elsewhere, we can refine our sense of what to seek here. All of this work is bound by a principle of humility. Our tools are powerful, but our vision of deep time remains narrow. A few cores, a few isotopic signatures, a handful of anomalies against the immensity of Earth's history. These are only fragments. The absence of evidence cannot prove absence, and the presence of anomalies cannot prove civilization. What remains is the discipline of the search, the sharpening of questions, and the recognition that our ability to know is limited by the planet itself. In this humility lies perhaps the most profound truth of the Silurian hypothesis. To ask if others came before is to confront not only the mysteries of Earth's past, but also the fragility of our own future. If civilizations vanish without trace, then so may we. And if our tools are limited, then so is our certainty. Science may never resolve the question completely, yet by asking it, we learn not only about Earth, but about the precariousness of intelligence, the impermanence of progress, and the silence of time. The Earth is a palimpsest, a manuscript of stone, written and rewritten across billions of years. Its surface is not a faithful archive, but a restless canvas. Mountains rise, only to crumble into seas. Oceans expand, only to retreat into deserts. Continents fracture, drift and collide, carrying with them the faint traces of lives long extinguished. Each age writes its story upon the world, and each story is eventually erased, leaving only fragments, shadows, whispers. In this way, the Silurian hypothesis does not simply ask about the past, it reframes our place within time itself. If we are not the first, then our story is not singular. It is part of a cycle that may be older than memory. Civilizations rise, carve their names upon the world, and fall into silence. The planet forgets, and time, indifferent, turns the page. The emotional weight of this truth is heavy. Every civilization believes itself eternal. Rome imagined its empire as everlasting. Ancient dynasties inscribed their triumphs in stone, believing they would endure. Even now, humanity's skyscrapers pierce the sky with a defiant permanence. Satellites orbit above as if to declare our dominion, and digital archives promise to preserve our knowledge forever. Yet the Earth teaches another lesson. Permanence is an illusion against geologic time. Even the mightiest works crumble into dust. If there were others before us, their arrogance too was erased, their monuments dismantled by tectonics, their machines reduced to ores, their histories swallowed by oceans. If they believed, as we do, that their story would endure, then the silence of the rocks reveals the truth. The Earth forgets. And so the haunting question turns forward. What will become of us? In 10 million years, what will remain of humanity? Perhaps a thin layer of carbon, a scattering of radioactive isotopes, traces of plastic pressed into stone, a geological whisper, faint and incomplete, to future beings. Whether human descendants or something else, we may be nothing more than an anomaly, an unexplained signal buried within strata, debated but never resolved. Here the Silurian hypothesis shifts from speculation to warning. If we are not the first, then survival is not about dominance, but about memory. It is not enough to rise, to endure. A civilization must find ways to carry its story beyond the erasure of the Earth. That may mean preserving knowledge off-world, scattering archives into the stars, ensuring that intelligence does not vanish silently into dust. To remain only as a carbon spike is to fail the test of permanence. The hypothesis also reframes destiny. If civilizations are cyclical, if rise and collapse are the rhythm of intelligent life, then perhaps our task is not to escape this cycle, but to understand it, to recognize fragility, not as weakness, but as truth, to measure our progress, not in monuments, but in resilience. The Earth may forget, but memory can endure elsewhere if we choose to carry it. Yet within this reflection lies a profound humility. Even if we succeed in scattering our knowledge, even if we endure longer than those who may have come before, we remain bound by the same cosmic silence. The stars do not speak. The rocks rarely reveal their secrets. Perhaps eternity is not about living forever, but about understanding that our story is one among many, written upon a page that is never permanent.